Hello, my name is Sean Boyle and I teach here at Southern Illinois University, and this video is going to cover the NAG, or Mercedes 722.6 torque converter operation. This is part of a multi-part series where I've covered the 722.6 overhaul, mechanical operation, hydraulic operation, electrical operation, and there's even a video with the aftermarket enhancements and improvements. So to find those videos, you can either go to automotivetextbook.com, find the automatic transmission curriculum link, or you can just look at the YouTube channel, find the automatic transmission playlist, and find all the 722.6 transmission videos. In this video, I'm going to show you on the bench some specific stuff for hydraulics and how this converter works. But first, let me just give you a brief introduction to this here torque converter. It's a little different than your average torque converter. It's because it's got a multiple disc clutch assembly in it as opposed to a big plate. Now, if you don't know much about how torque converters operate, I suggest you go up here to the torque converter. There's a basics video on how torque converters operate, and watch that first. But now this right here is the complete converter, the complete donut. I've cut the weld open. This is the hub right here that drives the torque converter, and the engine bolts up to the back right here through the flex plate. We've got a pilot that helps center it in the back of the crankshaft. And this is getting heavy. Anyway, I'm going to go ahead and split this open. Voila. Now normally, like I just said, you wouldn't be able to do that. The fins that you see on this side, that would be part of the converter cover, and it's welded to it. So these fins are the impeller fins. These fins right here are the impeller fins. Matter of fact, I'll just lay this down. Whew. Yeah, so these are the impeller fins. When I start the engine up, the converter cover is going to drive this impeller, and it's going to take fluid from the center of it and fling it around to the outside, and what's going to catch the fluid is the turbine. So the turbine, through these splines, is connected to the transmission's input shaft. So the fluid is going to hit these turbine blades, and that's going to deliver torque to the input shaft. Now, any energy that's left over from when the impeller threw the fluid to the turbine and the turbine grabbed onto that fluid, there's going to be some energy left over in that fluid, and that is going to get redirected to the stator, and it's going to bounce off the stator. This is during torque multiplication. It's going to bounce off the stator in the same direction as engine rotation, and that's how you get your torque multiplication. It's like a recycling of leftover energy from when the impeller threw the fluid to the turbine, and then it returns that fluid to the impeller in the same direction the impeller is going or the engine's going, and that assists it. What makes this converter different, as you can see, we've got a hub right here, and that hub grabs onto a multiple disc clutch assembly that's kind of built in to the converter housing. And we're going to see some more of this on the bench here in a second, but fluid pressure from the tip of the input shaft is going to move this piston out and compress this clutch pack. Normally this clutch pack is released, but when hydraulic pressure gets behind that piston, it compresses that clutch pack, and now my engine can drive through that hub. Once that clutch is applied, it can just directly drive the input shaft. That's what happens when this torque converter locks up. Now, another attribute that goes along with having this multiple disc clutch assembly is that this torque converter is going to be what's considered a three-path torque converter. We're going to have two paths to deliver fluid in and out to the converter, and the third path is going to be applying that torque converter clutch piston. Your average torque converter on most vehicles that are two-path, you have fluid going in and fluid going out. And when you want the torque converter clutch to apply, they reverse that, and the direction of how fluid is finding its way into the torque converter is going to determine whether in your lockup mode or in your release mode. Once again, not to sound like a broken record, but if this doesn't make any sense, you need to watch that intro video to torque converters, and I explain all that in there. So when we get to the bench, I'm going to show you the specifics on how fluid gets to this piston and also how fluid goes in and out of this torque converter. So before we go over to the bench, let's cover some theory on how this torque converter operates. This slide right here shows the electronic side. This is the conductor plate that's located on top of the valve body. The main component for our torque converter is going to be this lockup solenoid. It's going to determine how hard or how much force this lockup piston is going to apply. And other components, like our speed sensors, our N2 and N3 speed sensor, they measure input shaft speed. And they are also important because the crankshaft and the transmission's input shaft, those speed sensors are going to determine how much torque converter slip is occurring. So when the TCM wants the torque converter to lock up, they're going to energize the lockup solenoid, They're going to closely monitor engine speed and input shaft speed to determine how much force they need or how much pressure they need behind that piston to lock up and get rid of all the slip, or at least most of the slip. Some of these other solenoids that we have here, these are the shift solenoids to get our shifts to occur. And then we have a line pressure solenoid and a shift pressure solenoid. Obviously, our line pressure solenoid could affect torque converter clutch operation, but we would pretty much focus on that lockup solenoid if we have torque converter issues. Now it's your favorite time, hydraulic schematic time. Let's look at the hydraulics on this torque converter circuit. So we're going to really focus on this area of the drawing right here. And we're going to see in red, that's line pressure. Line pressure finds its way down to this torque converter pressure limit valve. It's also called the lubrication regulator valve in a lot of service manuals. So it's a basic regulator valve. Matter of fact, it's just got a spring. There's nothing real fancy going on with it. So when pressure builds up to about 100 psi, it cuts itself off. So this is actually drawn in the position where it looks like it's cutting itself off there. So that what's basically going to happen if there's no pressure at all, the spring would move this valve over to the left. It would allow as much line pressure as it can in there. And then as pressure, that same pressure that's letting in, is exposed to this balance end of that valve, it's going to start compressing it up against that spring. And eventually it's going to move it over to the point where it blocks it off. And that is its regulating point. And that means it's going to see a maximum of 100 psi. That's the goal. And if line pressure is 60 psi, it lets all 60 psi in there. But as soon as the line pressure goes above 100, it caps it off there. It doesn't let it go above 100. Then if we keep following along, traveling through, it goes to the lockup control valve. Now right now this is in the released mode. You can look up here where it says lockup PWM solenoid. It's not energized and there's no fluid pressure going through that line. So we're in the release mode. That fluid is going to find its way in. It's going to find its way into the torque converter. And by the way, this is how they draw and how they represent a torque converter. This would be like the impeller. That's a little line right there showing it finds its way over to the engine. That's the torque converter clutch, the multiple disc clutch assembly. And this is the turbine finding its way over to the input shaft. And this is the stator. So it's the impeller, turbine, stator. And that's actually a one-way clutch right there, like the little rollers of a one-way clutch. So anyway, going back to the hydraulic flow, so fluid's going to find its way into the converter, and then it finds its way back through this passageway. Kind of step back there. It goes back through that lockup valve, finds its way through a bypass valve. These bypass valves, if the pressure differential is great, it'll bypass it, like if your cooler gets plugged. That's kind of the idea behind it. But under normal operation, that cooler wouldn't be plugged, and the fluid would find its way through the cooler circuit and then into the lube circuit and find its way back into the oil pan and recycled back up again. So that's how this converter operates when it's in release mode. It's like I mentioned earlier, it's a 3-path converter, but fluid's going to find its way in here and then out there. So it's looking like it's just a 2-path here, but that 3rd path is for our lockup, and it's not being used right now because we are in release mode. Now this hydraulic schematic here shows lockup mode, and you can see the difference is our lockup PWM solenoid turned on. This is fed with 50 to 55 psi. So they modulate this on and off. And so that means they can deliver anywhere between 0 and 50 psi to the lockup valve. That's the reason why they changed the color to green here. So we're going to receive between 0 and 50 psi to shuttle this valve over. Once this valve shuttles over, a couple things are going to happen. One is my line pressure. I still have that 100 psi there. If you take a look, it still finds its way in to the torque converter, finds its way back out, but it kind of gets splattered out right there. It kind of gets opened up to vent. Now if you look right here, that 100 psi does still kind of allow for fluid to find its way into this cooler circuit and this lube circuit. So it doesn't cut it off, but it when that valve shuttles over, it basically finds its way into this lube circuit through a different path. It doesn't come from the converter. The fluid that's being pumped into the converter wraps its way around and gets exhausted right there at the lockup control valve. Now, the big thing that happened when we turned this lockup solenoid on is we now are taking line pressure and we're modulating it and finding its way into this converter circuit. Now, this is still kind of like a regulator circuit. It's not going to let full line pressure into the circuit. So you can see it says between 0 and 118 psi. That's what it's going to be limited to. So we're going to have our full line pressure coming in, but you can see it's kind of polka dotted colored fluid there coming out, because they're going to regulate that to 118 psi. Depending on how much fluid pressure, this green pressure, exists on the end of this lockup valve, that's going to determine how much force or how much pressure is going to find its way into that apply piston for the lockup. 0 to around 50 psi is what they're going to deliver to this lockup control valve to control line pressure and give you between 0 and 118 psi. Now these are all published specs. Unfortunately, you don't have any real good way of measuring this. You can check cooler pressure, and that will give you an idea of your torque converter pressure, but there's no way to go in. There's no pressure taps to check lockup pressure. There's no pressure taps to check line pressure or anything like that. Okay, now that's enough on the hydraulic schematics. Let's go over to the bench for a minute and see how this thing really operates. So now we're here on the bench. We can get all up close and personal to some of these parts here. This is a converter that has not been cut open. You can see the weld is fully intact. This is the hub portion, the part that's going to grab onto those pump gears and spin them. So when my engine starts up, I start spinning my pump and I start generating some pressure in the transmission. And that centers it to the transmission, this centers it to the crankshaft. We got our mounting pad so we can bolt it to the flex plate. But aside from that, we can't see anything in it. So that's why I've got this one here. We can actually go through and look all the little goodies on the inside. Cut that weld open so we can see right here. I've got my impeller. This is the engine driven part. This is normally part of the cover, so when the engine starts and it's running, it's going to take fluid in there, fling it out, and what's going to catch it, as I mentioned, is going to be turbine. And the turbine is going to receive that fluid, transfer some of that torque to the input shaft, and you can see this splines right up to that input shaft, like a dream. And then this part of this hubbed part that we have here, it's got some cushion springs and so forth, that's going to grab my multiple disc clutch assembly. Normally that clutch assembly is released, so like if I put this together, you can see it could spin in there, right? It's not connected. You can see everything spins separate, right? And now if I take air pressure, I pump it into this hole right there, it's going to apply this lockup piston. And once that piston's applied, pressing that clutch pack, I've just locked my cover to my turbine and my turbine to my input shaft. So in effect, I've locked my cover to the input shaft, and my engine, through those little cushion springs, can drive my input shaft. We talked about this being a 3-path converter, so one path is just basically going there and applying our lockup piston. And here's the thing, if you look close, I don't have a piston return spring to push that piston back. So how do they get that piston to release when they don't want the converter clutch applied so they can get the grab off of these clutches? Well, remember, this is filled with up to 100 psi fluid pressure, so I'm going to have a bunch of pressure on this side of the piston, and it's always going to keep that piston pushed back. That is if everything is working the way it's supposed to. And this torque converter does have issues. We've got a couple issues. One, kind of related to this path number 3, which is going to be coming in from my input shaft, is there is a seal deep down in there, and that seal has a tendency of leaking. It shrinks apparently, or it gets too soft, and it does not do a good job of sealing. That inner seal needs to seal off this surface area. And if it doesn't, the fluid that's coming out of the input shaft finds its way past that seal and leaks out. And another thing, that this portion of the input shaft is a little narrower than this portion. So they don't use a seal in this area inside the converter, so they rely on this small clearance fit that exists between the input shaft here and the bore in this aluminum center section of this torque converter. So if this wears out, fluid pressure that's in the converter that's not supposed to be a part of the apply circuit can find its way in, get behind the piston, and partially apply the converter. And that is not good. I'll go ahead and pull this snap ring off. They only put a couple friction discs in there, a couple steel plates. Now the aftermarket, and you'll see this in a second, Sonics makes a special plate setup that has a spring that kind of pushes this all back, kind of like a piston return spring, but it's a very small springs that go in there, and it's designed to help keep that piston retracted. And the reason why they do that is sometimes the pressure in this converter, if you've got issues in the valve body, you might not have the pressure in this torque converter like you should. If you got any cross leakage that's occurring, that piston through centrifugal force, remember, if this thing's rotating, fluid behind this piston is going to want to find its way towards the outer diameter, and that could centrifugally try to apply this piston. There's no way for fluid behind here to get out. They rely on the torque converter pressure to push this piston back and kind of reverse all the fluid that's in there. But if you don't have that much pressure pushing this back and this torque converter spinning fast enough, centrifugally it might have enough force to drag that piston on. And that's where the problems happen. I'll go ahead and pop this piston out so we can see what's all about. All right, I got it mostly out of the bore there. It didn't just fall out, so I'm gonna have to get loud. There we go. So there's 3 little slits right there. And those are what allow the fluid to find its way in behind that piston. And you can see I also have a kind of a square cut seal in there. It's something that a converter rebuilder is going to not only want to replace that one, they're going to want to replace that seal that's deep inside here where the input shaft is designed to kind of fit around. And they also want to make sure that that diameter is not too large. This is just aluminum and it might wear. And the piston itself is pretty lightweight. There's not much to it. We got an outside seal on it. It's like a D-shaped seal. But I have heard of these pistons cracking. And once again, if this piston cracks, fluid that finds its way on the other side of the crack is going to build up on this side, might drop the pressure in the converter, and when this is spinning, it could cause this thing to centrifugally drag on. You might notice I'm talking a lot about that TCC piston and the torque converter clutch apply circuit. It's because that's probably the biggest problem that you have with these 722.6 transmissions and their converters. So knowing what can cause torque converter clutch issues internally in the torque converter as well as in the valve body and so forth, that's good stuff to know. Sonics actually does make a few different thickness snap rings for this too, so if you can't get your clutch back clearance that you want, you've got options. Okay, so now we know how the fluid finds its way into that torque converter apply piston. How does fluid find its way into the rest of this converter? If you watch the overhaul video, you probably recognize this assembly as the B1 clutch housing. This right here applies the B1 clutch. Well, it also kind of is a pathway for fluid because it's part of the stator support shaft is included there. There's a little snap ring that holds the stator support shaft in. And the way they get fluid into this torque converter, not for the torque converter apply circuit. The torque converter apply circuit finds its way in through this hole, around a sealing ring, and comes out through those little holes right there, just like I showed you before. So we covered this passageway here for that lockup torque converter piston. Now we're going to look at how the fluid just gets in and out of this converter for the other 2 paths. Well, the way fluid finds its way in is going to be between the stator support shaft and the torque converter hub. So when this is all assembled, here's the torque converter hub. When this is all assembled, fluid is going to get directed from the bell housing right in between the stator support shaft and the torque converter hub. Fills the torque converter up, that finds its way back between the input shaft and the stator support shaft. And you can see there's a hole right here, and that's lined up. So that fluid that finds its way in between the turbine shaft and the stator support shaft comes out through that hole, finds its way over to the bell housing, and comes out of the bell housing, it's directed over to that lockup control valve. And from there, if the lockup is applied, if we're in apply mode, this fluid's going to get drained off to the pan. But if it's in release mode, that fluid's going to find its way to the oil cooler and through the lube circuits. So those are our 3 paths: the lockup piston, fluid entering the converter, and fluid exiting the converter. So to finish off our bench discussion, let's look at the valve body and focus on some of these torque converter related valves and see how they operate. Now here's a normal valve body, unmolested, not destroyed, not cut away. And that right there is a lockup solenoid. So that's going to be the solenoid responsible for shuttling the lockup control valve, the lockup regulator valve, and also determining how much torque converter clutch apply I've got. It's a low resistance solenoid. It only has like 2.5 ohms. It's pulse width modulated. And then these are our 2-speed sensor circuits, our N2 and N3. They measure input shaft speed. I mentioned that these are important. If you don't have functioning input shaft speed sensors, you're going to be in limp in mode anyway. But they're going to use the input shaft speed to determine proper slip speed for the torque converter. So it is important. And this right here is a cutaway of the lower valve body. I cut this away so we can maybe get a better understanding of how these hydraulic circuits operate in this. This right here is the torque converter clutch piston damper or accumulator. And if this thing is worn out, you can actually get a drop-in valve that Sonex makes. We'll talk about that in a little bit, and that will kind of restore that operation. This right here is the torque converter clutch lockup regulator valve. And this is very important, so we're going to focus some time on it. It is going to oscillate back and forth and regulate how much pressure we have in our torque converter clutch apply. Taking a close look at this lockup regulator valve, the lockup solenoid is going to operate on this end of the valve. It's going to shuttle it over. Now, the line pressure from the transmission is going to find its way into this passageway right here. And when the lockup solenoid moves this valve over far enough, it's going to allow line pressure to find its way into the apply circuit. Now, if you look, the surface area here is smaller than the surface area across there. So as line pressure finds its way into the supply circuit, it's going to work on that land and it's going to close itself off. It's going to overcome the pressure that I have from my solenoid on this side. If I want more line pressure to find its way into the apply circuit, a pulse would modulate the solenoid on more to increase the pressure. Remember, this is up to 50 psi over here. As they increase the pressure, they're going to allow more line pressure to find its way into the supply circuit. The way this valve is designed, if the solenoid is fully applying all 50 psi here, it'll let about 118 psi into the apply circuit. So now these two passages right here feed the converter with oil. This is part of the other two circuits that we have in this three-path torque converter. Fluid will find its way from this valve to the inside of the converter, and then it'll return to this passage, and it'll find its way to the oil cooler. So when we're in full lockup, this inlet passage that is part of the other two circuits for the torque converter is blocked off. It can't do anything. But now this passage right here can still feed the converter. So it's still feeding the converter, and the fluid that comes back from the converter goes to this vent, this passageway right here, and it gets vented off into the pan. Now what feeds the lubrication circuits and the oil cooler circuits, you say? Well, if you notice, there's a gap right here, that this land right here isn't sealing off on this bore. So fluid that feeds the converter also sneaks past and finds its way into the oil cooler and the lubrication circuits right here. That's why it's very important that you got a good lubrication regulator valve, or it's also called the torque converter regulated limit valve, because it is feeding all this volume of fluid to the cooler circuit and to cycle the fluid in and out of the torque converter. Now you can have issues with bore wear along this lockup valve. If you have bore wear, you can actually have a lazy apply with your solenoid. It's not going to apply the amount of force to that valve as you need. It's also going to be able to leak past some of these lanes here. So Sonex, as you'll see in a little bit, makes an oversized valve where you remount this bore and get fresh metal in there, and then you put a new oversized valve in there. They also make a kit for this torque converter clutch applied damper. If this bore wears out here, they basically have a drop-in valve that puts new seals in there and has a new piston and a new spring, and it'll work as an accumulator for the lockup piston. Kind of restores all that. Now this valve right here is a lubrication valve, and it's also called the torque converter limit valve or torque converter regulator valve. It's what regulates the pressure that goes into the torque converter to 100 psi. So line pressure comes in right here, and as line pressure finds its way into that torque converter circuit, it also finds its way to the back, to the reaction end of that valve. And it's going to move this valve over to the point where it can cut off its own supply. So it's always going to regulate into that position, and the strength of this spring is going to set the pressure that exists in the torque converter to about 100 psi. So issues can happen when this bore wears out and that oil leaks past and we can't build up that 100 psi of pressure in that torque converter circuit like we need. So hopefully this all makes sense and how these valves operate and what they do. How do you know if there's anything wrong with them? Well, if you watch the overhaul video towards the end there, I cover vacuum testing the valve body. That's a good way to determine if these bores are worn out. If they are worn out, that gives you information on maybe that's the root cause of the failure of the transmission, or if nothing else, that's something you might need to address so that way your rebuild doesn't end up failing. A lot of techs are going to go through and put kits in there. They're going to put Transgo Kits, Superior Kits, or do some Sonex modifications. Let's go take a look at those modifications and see how we can improve the torque converter clutch circuits on this transmission. So now that we've gone through this converter on the bench, let's go and take a look at it here. This is an image that Chrysler's provided. And it's basically a bandsaw. Slice this thing in half. We can kind of take a look at how this is constructed. Everything in purple here, that's the impeller. This is the impeller. It's the engine-driven part, right? And then everything in this kind of tannish, brownish color, that's the turbine. The turbine finds a way. It's connected to the input shaft to the transmission. In between the two, we've got the stator, And there's our torque converter clutch right there, multiple disc clutch assembly. Really what this is showing is fluid flow. And you can see the fluid finds its way in between the torque converter hub and the stator support shaft. So it finds its way just like we looked at on the bench. But then it finds its way back between the input shaft and the stator support shaft. And then the apply fluid for the torque converter, the third path there, finds its way in right through there behind the torque converter piston. That seal right there, remember, very important. We don't want to have that being loose or have an issue because it will leak off pressure. And then even this little center section that centers the piston, there's a small clearance that needs to exist between the input shaft and that. If that is too large, you will leak that fluid, or actually you can leak pressure into there and drag this clutch on when it's not supposed to be on. That's bad, not good. You might be like, well, what does this even matter? Because I can't get to the insides of this. I'd have to cut the weld off. I'd have to have a lathe and all that stuff. And then what would I do if I had it apart? So it is still important. The reason why it's important is because when you order these things and you order them from your reman company, you want to find out what kind of modifications they've done, what kind of improvements they've done. There's a lot of things that you can do to these to make them better. And we'll look at some of those modifications here in a second. But I mean, thinking about that seal right there, if that seal's leaking, you're going to have issues. If the clearance between the input shaft and the center section here is leaking, you're going to have issues. If you don't have your clutch pack clearance set right, you got issues. So you're going to want to go through and, if nothing else, especially if you're running into issues with your torque converter, and this is a reman converter, you want to find out what's been done internally to this to make sure it's got the latest updates. So talking about improvements, things that you can modify on the inside of this transmission. Sonex is a company that's kind of known for a lot of transmission and torque converter enhancements. Well, this is one thing they've got. This is a clutch release kit. When we had this apart on the bench, you notice that there's no piston return spring. They rely on the fluid pressure in the torque converter to kind of push that piston back when it's not being applied. Well, this right here is going to help push that piston back. You basically take those steel plates that exist there and you replace it with this. The top and the bottom are replaced by this. And what this does is it has a tiny little springs that fit around there, and then little spots for those springs to kind of snap into or fit into. And that keeps the top and the bottom plate separated. So that way the clutches are not going to be dragging. So this could be good for you if you've got a vehicle that has like an engine that wants to stall, especially like a cold start situation. It's idling, it's kind of dragging that torque converter. You can feel it, that this is a component that might relieve that. Another thing is they made that updated seal. If you remember that seal that was inside there, that is one that apparently shrinks or gets too soft and it does not do a good job of sealing off. Well, they've made an improvement one where they got a Teflon coated and it's supposed to last a lot longer. So those are just a couple of examples, but they also have other things, like they've got a variety of clutch packs that you can put in there, different thickness snap rings, different thickness steels, so you can get your clutch pack clearance exactly the way you want it. They also make different modifications for the valve body. Like this is an example, the oversized lubricating pressure control valve. This is a pretty common failure in these transmissions. It's one of these areas that you'd want to vacuum check, just like I did in the overhaul video, to find out if you've got leakage. And the reason why this is super important is because if you lose this, this is the valve that ultimately develops the pressure, the regulated pressure for the torque converter, that 100 PSI that we talked about. If this is worn out and we're not getting 100 PSI into that converter, then we're not going to get the amount of pressure to push that torque converter clutch apply piston back and retracted, and that could contribute to that clutch dragging. And a worn out lubricating or torque converter regulator valve is going to result in poor cooling, potentially, and also poor lubrication. Because remember, this is the fluid that comes from the converter gets routed back through the lubrication circuits. So if I'm leaking a lot of that pressure off, it's not finding its way in the converter and not finding its way through the cooler and not finding its way into the lubrication circuits, all those areas could suffer. So you can run into the same issue with our lockup regulator valve. This is the one that the solenoid works on. And if you've got a worn out area here, like for example on this board, and you find that out by vacuum checking, just like I did in the overhaul video. But if this was worn out, that solenoid pressure that's coming from our lockup solenoid, it's not going to modulate or move this valve like it should, and it's going to end up not allowing as much line pressure into that torque converter apply circuit. And then we're going to have potentially some slippage or some weak torque converter clutch apply. I'll have a little more information on this with the enhancements and improvements video, but just the kind of the gist of it, it does require a fixture, it does require a reamer, so it's not something you can just drop in. It is an oversized valve, so you actually have to go through and fit this up in a jig, you ream it out to get a nice fresh new bore, and then you can put their nice new anodized valve in there. It kind of brings things back up to factory clearances and tolerances. Now Sonex also makes this torque converter clutch damper kit for the later units that use a damper valve. The earlier ones didn't have it. What it does is basically an accumulator for the torque converter clutch apply piston. And if it's worn out, you're going to end up getting harsh torque converter clutch apply. So their replacement one doesn't require any reaming or anything like that. You can put the sleeve in there, put these O-rings on there, kind of clips that in there, and we've got the valve. And this bushing and valve that they put in there is a much higher quality aluminum than what they had from the casting from the factory, so it lasts a lot longer. And also, related to the torque converter clutch circuit is our regulator valve. So for our overall, our line pressure regulator valve. So if it's not working properly, you're going to want to address that as well. Now companies like Transgo, they make a drop-in valve. Sonex, they go ahead and oversize it. They ream this out, and then they put in an oversized valve, just like they did the lockup regulator valve, and they put their springs in there. Brings everything back to OE operation, but you do have to use a reamer and a fixture to go through and do this. Now Transgo has a kit for the 722.6, and they basically package this kit and addresses a bunch of different issues. And you can see they've got this drop-in pressure regulator valve right here. It's made out of steel, because steel is real. And they make all their valves out of steel, really. And then this right here is the lubrication regulating valve. It's made out of steel. It has its own little bushing that's designed to fit into it, kind of establish a good clearance between these two. Has a little sleeve for the spring to ride in there and a new spring, so that way it's got stability to it. And then these are overlap valves. And then also some replacement springs for common valves that have a tendency of breaking their springs. So when you buy this little Transgo kit, it comes with the major areas that this valve body has issues with. Now Superior, they make their kit and they focus on the lubrication regulator valve. And you can see you got 5 lubrication regulator valves, a reamer, a buddy bore brush, and a little jig for alignment. And when you ream all this stuff out, basically that one reamer and 5 valves, you can do 5 transmissions with their kit. And you can go through and buy individual valves, but basically, I think the idea there is that after 5 valves, you've maybe worn out your reamer enough, you probably should get a new kit anyway. But their kit can do 5 transmissions, so that's kind of nice. So that kind of sums up the torque converter presentation here for the 722.6. I covered how it operates, how fluid flows through it, some common failures, some things to look at. We even took a look at the inside, which is something that we normally can't do. I cut away a valve body just for you guys so we can see how these valves are functioning and operating in there. So hopefully this all made sense and it helped you out and kind of give you an understanding of what's going on with the torque converter on these 722.6/Chrysler NAG transmissions. If you have any questions, please feel free to comment. Otherwise, thank you, and I'll see you on the next one.